So let's take a look at now at how to solve an equation using algebraic steps. So if we have 5x plus 3 equals 13, remember the goal is to get x by itself. So we want to get rid of everything other than x from that side of the equation. To do that, what we're going to do is we're going to get rid of whatever is being added or subtracted first, and then we'll take care of what's being multiplied or divided by the variable. So in this case, first thing we're going to do is we're going to subtract 3. To get rid of that, now we have to remember that we have to keep the equation balanced. So we want to make sure that we do that from both sides. 3 minus 3 is going to cancel out. It's going to become 0. So on the left side, all I'm left with is 5x. On the right side, I have 13 minus 3, which would give me 10. At that point, all we needed to do now is get rid of this 5. So we'll do the inverse of 5 times x, which would be dividing by 5. And again, we have to keep it balanced. So we're going to do that to both sides. When we divide by 5 on both sides, 5 divided by 5 is 1. And 1x is the same thing as just x, so those 5s will essentially cancel out. On the other side, we have 10 divided by 5, which is 2. So our final answer for that one is x equals 2. Of course, at this point, we can check that solution by plugging it back in. So to do a check, we can just do 5 times 2 plus 3, and we want to make sure that that equals 13. So we would do our normal order of operations. 5 times 2 is 10, plus 3, which is 13. And we can see that, in fact, this is true. So that tells us that we know our solution here is correct. Don't necessarily need to do a check every single time, but it is a good way to make sure that the answer that you have that you came up with is correct. Example 2, solve 6y minus 6 equals 30. So again, the first thing we're going to do is get rid of what's being added or subtracted to our variable term. In this case, it's minus 6. So to get rid of a minus 6, we're going to do the opposite. We're going to add 6 to both sides. When we do that, minus 6 and plus 6 will cancel out, become 0, so that goes away. On the left side, we're left with 6y. On the right side, we have 30 plus 6, which is 36. From there, we need to get rid of the coefficient of y, which is a 6. So this is the same thing as 6 times y. To do the opposite of that, we're going to divide by 6 on both sides. And then we'll come up with our solution of y equals 6. Again, we could substitute that back in to check and make sure our solution is correct. But again, we're not going to go through that every single time. That's something that you can do if you want to make sure that your answer is correct. The next one, we have something that's slightly different here. We're seeing a fraction. So remember that a fraction is the same as division. So we just want to keep that in mind as we're solving this one. First thing, we're going to get rid of whatever is being added or subtracted. In this case, we have plus 3 on the left. So we're going to do the opposite, and we're going to subtract 3 from both sides. 3 minus 3 will cancel out, become 0. So on the left side, we're left with that fraction, x over 3. On the right side, we have 12 minus 3, which is 9. At that point, x divided by 3, the inverse of that, or the opposite of that, would be multiplying by 3. So we're going to multiply by 3 on both sides. The 3's are going to cancel out here, and for some people, it's a little tricky to see, to understand why that cancels out. So a lot of times what I like to do is I like to write 3 as a fraction, putting it over 1. And then we can see that if we cross simplify the 3 and 3, they would both just become 1. And then on the left, all we have really is just this x, because we're multiplying and dividing by 1. On the right side, we have to multiply 9 times 3, and we get our solution of x equals 27. Example 4, 9x plus 100 equals 460. Don't be afraid of those bigger numbers. The process is going to be exactly the same. So we see our variable on the left. We're going to get rid of what's being added or subtracted, which is this plus 100. So we're going to go ahead and subtract 100 from both sides. 100 minus 100 is 0, so that cancels out. On the left side, we're left with 9x. On the right side, we have 460 minus 100, which is 360. At that point, we're going to get rid of our coefficient of x. So the inverse of multiplying by 9 would be dividing by 9. And again, we have to do that to both sides to keep it balanced. And then we'll end up with x equals 40 when we divide to get our solution. Number 5, you can see is a little bit different. In this one, we have our variable now on the right-hand side. So it's kind of backwards from what we like normally. If you want to, you can start off by using the symmetric property of equality and just flipping that around and saying 3p minus 10 equals negative 8. That's one option. The thing is, you have to make sure that you're keeping the order of your term or the expression exactly the same. Don't flip this around and say 10 minus 3p. That's a common mistake that will result in a wrong answer. What I like to do is I like to a lot of times just go ahead and solve the equation like it is, and then use the symmetric property in the very end to get my variable on the left. So as I look at this, I see that here's my variable on the right-hand side. I see that 10 is being subtracted from that on the right. So we're going to do the opposite of that, and we're going to go ahead and add 10 to both sides. Even if you decide to flip that around, you're still going to be adding 10 to both sides as your first step. Negative 10 plus 10 is going to be 0, so that cancels out. On the right-hand side, we're left with 3p. On the left side, negative 8 plus 10 is going to give us 2, positive 2. At that point, we need to continue solving for p, so we're going to divide by 3 since it's the opposite of multiplying by 3. And in this case, the 3's cancel out. On the left-hand side, you see that's not going to work out nicely. So what we like to do in algebra is we don't like to go ahead and divide that and make it a decimal. We like to just leave it a fraction and, if possible, simplify it. Now, 2/3 is already simplified, so we'll leave it just like that. And the other thing we want to do in the end, again, we always want our variable on the left. So if you didn't use the symmetric property in the beginning of the equation, we want to now go ahead and use that and flip that around so that it says p equals 2/3. If we were to take a look at the check on this, it's going to be a little bit more complicated because we are going to be using a fraction in this check. However, if you go back to your fraction operations, the process will be the same, and you should come up with negative 8 on both sides when you simplify it. Example 6. First thing we want to do is identify where our variable is, which is on the right-hand side. If you want to, again, you can flip that around using the symmetric property and say s divided by 4 plus 15 equals 11. One option. If not, again, what I'll usually do is I'll just solve it as it is, and then I'll deal with that flipping around in the end. So with this, I see that 15 is being added to the term that involves s. So I'm going to go ahead and subtract 15 to get rid of that. I'm going to do that from both sides to make sure that I keep my equation balanced. 15 minus 15 is 0, so that cancels out. On the right-hand side, I'm left with s over 4. On the left-hand side, we have 11 minus 15, which is going to give us negative 4. From that point, s divided by 4, or s over 4, the inverse would be multiplying by 4 on both sides. With this, again, if we think about that 4 as a fraction, these simplify, cancel out. So on the right, we're left with just s. On the left, we have 4 times negative 4, which is negative 16. We want to go ahead and flip that around using our symmetric property of equality to then say that s equals negative 16. All right, last two equations. These ones are going to involve fraction coefficients, so a little bit more challenging. However, our process is going to be very similar. In this first one, we see the variable on the left. We see that we have plus 6 here, so we're going to go ahead and do the inverse and subtract 6 from both sides. So we have 3/4 c equals negative 15. From there, it's difficult to divide by a fraction. So another way of canceling this out is using our multiplicative inverse property. So what we can do, our goal is to get this coefficient to be 1, because we really don't need it if it's a 1 in front of our variable. So we can use our multiplicative inverse property by multiplying by the reciprocal on both sides. So if I flip 3/4, I end up with 4/3. And if you notice, 4/3 times 3/4 is going to equal 1 because of our multiplicative inverse property. We have to make sure that we're doing the same thing to the other side. So we're going to multiply over here by 4/3 as well. It's going to require a little bit more calculation since we are now dealing with some fractions. This will become 1 and basically just cancel out on the left. So all we're left with is a c on the left. On the right-hand side, we can see that 15 and 3 can cross-simplify. If I divide them both by 3, this will become a 5. This will become a 1. So when we multiply straight across, we have negative 5 times 4, which is negative 20. And then 1 times 1 is just 1. So our solution here would be c equals negative 20. Example 8. See our variable is on the right here. And again, we have that fraction coefficient. We want to get rid of what is being added or subtracted first. So we see that 7 is a term that's being linked to that by addition. So since the 7 is positive, we want to go ahead and subtract 7 from both sides. So we can make that 0. 7 minus 7 is 0, which, again, will cancel out. So on the right, we're left with 2/7 e. On the left, we have 3 minus 4. Sorry, we have 3 minus 7, which is equal to -4. From there, because again, we have a fraction coefficient, we're going to go ahead and multiply by the reciprocal, which would be 7/2. That will cancel out over there. You have to make sure that we multiply over here by 7/2 as well. If I turn -4 into a fraction, -4/1, I can then cross simplify by dividing both of these by 2. So 2 divided by 2 would be 1. -4 divided by 2 would be -2. From there, we'll go ahead and multiply straight across. So 7 times -2 would be -14. 1 times 1 is 1. So we have -14 equals e. The last step will be using that symmetric property of equality to flip that around and say e equals -14. All right, that's the end of our guided notes for today. So if you have any other questions, please feel free to ask. Thanks.